Well, thanks for staying with us. And you know, when you think about it, the responsibility for preparing today's students for their future is pretty awesome. I mean, I always feel like we're trying to prepare kids for a future that's hard for me to even imagine what it's going to be like.
That's right.
But thank goodness we've got some amazing teachers like Russell Stilley, who is our technology teacher, one of our technology teachers at Atascocita High School. And Russell, thank you for bringing with you Renee Raines, one of our sophomores at AHS. And what we're going to... I'm sorry?
Junior.
Look at that. I put her back in her sophomore year. She is a junior officially.
That's okay. Women don't mind you making them a little bit younger.
Sorry, Renee.
Okay.
A junior. But thank you for being with us. And really what we want to share with you is yet something else that our Education Foundation has provided actually to Mr. Stilley and his classes, thanks to his initiative of asking for it. And it's called a 3D printer. And Russell, I want to ask you to explain it because the only way I know how to explain it is it's magic. So what is a 3D printer?
Well, if you know how a regular 2D printer works, you send an image from a computer over to a printer and it prints on a flat sheet of paper. Just imagine if you could have a computer program that sends an image over there and it prints one image, one layer, like a flat piece of paper, but then if it's printing on a table, it can lower the table, print another image right on top of that previous one, lower the table, print another image right on the top of that one, and eventually you'll have a 3D shape. It prints in a material that's plastic, the one we use, and it's plastic similar that you would find in a weed trimmer. It's kind of a thin plastic line, and this material is heated up in a mechanism that's similar to a hot glue gun. So if you know how a hot glue gun works, it heats up that material, squirts out one end hot. It does the same thing, except it prints it on the table one layer at a time. So as it's cooling, the table drops, prints another layer, table drops, prints it again. And the computer controls where the hot glue gun tip is. And it'll get all the way to the end. By the time it gets to the end, it's ready. You can just pick it up right off the table and it's a 3D object. I brought along some samples from our class. We teach engineering design and architectural design classes where we use the 3D printer. And one of the objects that we printed up was this shape right here. In the class, we actually have to draw it on the computer. We use a program called AutoCAD. So we draw it in a three-dimensional shape like this, and then the students can print them out. Sometimes we'll have special projects to where in an architectural design class, they'll get to design their own house. And we print out a copy of their house, everything from the details of the walls and the roof line. And in our class, we also have engineering design, and it's the project that Renee worked on. It is a project to where we made it to where they work on a medical device that I noticed a lot of my kids that come into my classroom, they'll maybe break their arm skateboarding or whatever, and they'll have a cast up to their knuckles. And if they're having to take notes, sometimes it's hard for them, if they're right-handed, let's say, and they have the cast on the right hand, to grasp a pencil and write with. And so they would have to write with their left hand. So I was thinking, maybe here's a good application of how to put this to use. Have the engineering design students figure out a way that if you have a cast on, maybe invent some type of device that slides over the exposed fingers that will grasp the pencil for you and allow you to take notes with the correct hand. If you're right-handed, you take it with the right hand. And so that's the project that Renee worked on in engineering design class.
So you design it in actually... See, I told you, it's magic.
This is so cool. Renee, when you first started this class, did you have any idea this is what you were going to be working on?
No, honestly, I didn't actually know how cool the 3D printer was and what you could do with it, but by the end of the year, it was amazing what we could just print. I mean, like pretty much anything we could do.
So do the students come up with the ideas, or does the teacher, or do you collaborate on what you want to print or what you want to create?
Well, he came up with, you know, the project idea, like exactly what to design, but we came up with the actual design ourselves, you know, how it looks and, you know, how it works. So
Renee, how does that work? Or how would it work?
Well, I'm left-handed, so I do it like this. But say you had a cast on your hand, or you have carpal tunnel, or you know, broke your arm or something, or your wrist, and you need to be able to write. And writing with your other hand is, you know, a little bit hard. So what this does is you insert your pencil right in this little spot here, and you do the little, motion for writing, and that's how it works. You just.
How cool is that?
Okay, that begs the question of patents. Do you have plans to patent devices that your students work on, or?
Not right now. Other people have actually worked on some ideas similar. Well, the goal of this project was to, one, get them to think creatively, not just dictate to them what they should make, but to get them to think what kind of shapes should they make, so they're applying what they've learned in the previous semester. We usually do this in the second semester. So apply what they've learned, how to make a three-dimensional shape, figure out what the thing looks like themselves, then we print it out and then we test it. But as far as the patenting of it goes, no, we haven't done that. We do a little bit in the class where we learn about patents and we learn the process of getting a patent. But on this particular one, we really don't go down that road at all.
This replaces hot pressing things, right? Like if you're going to create, let's say a Lego, because people can understand what a Lego looks like. Instead of a company that hot presses them with molded plastic, this can actually copy it and just build it from the ground up, right?
Yeah, what's unique about this product, the 3D printer, is that it can make unique one-at-a-time objects very quickly. For example, the Lego example that you gave, they have to make an expensive steel press that injects plastic into a cavity and prints it out, and those big steel presses with the cavity and the steel rolled die things are very expensive and they take a long time to make. But the unique thing why these are catching on is you can make one-at-a-time things very quickly without spending a lot of money on the tooling of it. These actually the devices were around for a long time. I used them before I was a teacher. I used them out in industry. About 20 years ago I used them to help create. I worked for Texas Instruments up in Dallas, and I helped design graphing calculators. And one of the things we did was we made three-dimensional shapes that we printed on these printers, tested them, do drop tests, temperature tests, all that type of stuff, tweak them real quick. But the problem back then was they were about $250,000 a piece. And recently the patents expired on them. So everybody's making them now, and the price is coming down, so much so that they're only a few $1,000s now. We can afford to have them in schools. So I was thinking, for the students that are getting ready to go out in engineering fields, architecture fields, they need to know about this technology that I've used for 20 years. And so here's an opportunity. Prices are down low. They can do it in class, get excited about it, and hopefully maybe choose that career to go into, either architecture or engineering. That was the main goal of even getting the whole printer in the classroom. It's just get kids more excited about those careers.
Well, and really, Russell, thanks to your initiative and expertise and the foundation support, really our kids have an edge. I mean, truly. And so, Renee, do you think this is a field that in general you may pursue?
Actually, yes, because I want to be a chemical engineer. Okay. And everything that comes out of, the little gun that shoots out the plastic, it doesn't have to be plastic. It can be a lot of different kinds of materials. And, for example, right now they're talking about, making synthetic arms and legs or even making food out of these things. And so all the, applications of, how we can use this 3D printer to make anything, chemical engineers are involved in all the designing how, the plastic or whatever chemical comes out and anything that goes in there. So.
Well, you are going to be awesome. That is
This
so
is
cool.
so cool. Well, you can make prototypes of anything, like teeth and joints and things like that.
Is not just printing plastic, it's printing all these new materials that they're coming up with. New materials including body part materials. So in the future, if you need, let's say, a liver transplant and you can't wait around for somebody to pass away and you get on the list to get one, they just take a DNA sample from you, print your own liver out that they put in you and will not reject it.
Well, for some of us,
serious?
Renee, isn't that something? So Renee, you really got to get busy on this for some of us, so we're okay.
That is amazing. That's amazing.
It is. Well, Renee, real quick, they're waving us on. We're running out of time, unfortunately. Any thoughts? I mean, you've got time, but any thoughts about the next school you may be interested in attending to pursue engineering?
Possibly University of Texas at Austin. They have a great engineering program there. So.
Great.
Wasn't what you'd hoped to hear, was it?
I know. I keep trying.
He's an Aggie through and through. So
My aunt is an Aggie too. She's going to be disappointed.
Okay. Well, good. At least your aunt is an Aggie. That's great. Well, Russell, thank you so much. We are just so blessed and fortunate to have you in the family, and appreciate all you're doing with and for
Thank you.
our students. Renee, it was great to have you. Good luck, and do get busy on those body part things. Some of us may really need that at some point. So, thank you all. Stay with us, and Lynn and I will be right back.